Okay. Hello, everybody. Today, I'm just going to talk about Retrieval-Augmented Generation and more like a Generative AI 101 session. And yeah, by the way, Estrabla, are you recording the session? Is it started?
Yes, yes.
Okay, cool. So, first of all, I'm Mert. I'm still a student at Bursa Technical University. I'm in the fifth year and studying computer engineering. But when I started college, when I started university, I also started my self-learning journey of artificial intelligence and machine learning. And after some time dealing with the data analysis, data engineering stuff, and machine learning stuff, I found myself in the generative AI space and did a lot of projects in the hackathons using RAG systems and generative AI projects. Okay, so the outcomes of this launch and learn will be more like where we are in the terms of innovation in the generative AI, state of the art, and what is going on in the generative AI space right now. And also, I'm just going to talk about RAG, Retrieval-Augmented Generation. Why does it matter? And why we are using RAG, and why it's useful, and how to implement it. So first of all, these are like some points that probably everybody should know. So right now in the generative AI space, in the AI space generally, NVIDIA is the most powerful company with $3 trillion. And since they're selling shovels, like they're making a lot of money out of it. And also from the state of the art, state of the AI 2024, it was more like a research and industry white paper, and it says a Hollywood grade production makes generative AI in their visual effects and also in their movie making pipelines. And also, everybody knows ChatGPT was the fastest application to reach 100 million monthly active user, and it did so organically in just 6 weeks. And also, as far as I remember, they just hit the 1 million people in just 5 days or something like that. Correct me if I'm wrong. And these are some large language models that most of the people can use. Cloud 3.5 Sona is really useful in the mathematical operations and the math pipelines. And also there is Meta Llama 3. So first of all, Llama 1 came out, and then Llama 2, and then Llama 3. And then after Llama 3, they just updated the Llama 3 model to the 3.1 and 3.2. So right now it's Llama 3.2, the latest updated version. And also in the benchmarks, I saw that GPT-4o is the best out of three of them because they just updated their ChatGPT platform to be more like Canvas. It's the same thing with the Anthropic did with the artifacts. I'm just gonna show it to you. Don't worry. So first of all, what is RAG stands for? So retrieval is the finding the relevant documents for your question. When you ask something to the system, you are getting the relevant documents out of vector database. And then this is useful because you are finding the relevant documents and adding these reference to the context of the LLM, context of the LLM call. And then LLM will generate answers in a way that is aware of your context. It's called in context learning. And so these documents will be making your LLM much more accurate and getting better answers out of it. But first of all, in this ecosystem, you need to understand what is vector embeddings and vector database. So we have a lot of data. It can be unstructured or like structured. This is like voice data, images, or like documents, PDF documents. So you're just turning these documents into chunks, or like these unstructured data into embedding model. And this is text, this is image, and this is voice data. And then out of embedding model, you are transforming these data into vectors. But these vectors should have valuable insights in it. So it shouldn't give wrong meanings, like, because in the text, in the video, or like in the voice, there are a lot of different meanings that you can extract from. And this embedding model is the uh, like game changer in here, to transform those documents, those data, into meaningful vectors. And after that, we are just uploading these vectors into vector database. It can be, there are different vector databases. One is from Postgre, it's called PG Vector. One is called SQLite, one is called SQLite Vec, which is plugin for the SQLite database. And this is like how you can get vector embeddings of your data, like unstructured and structured data. So it looks like so simple, right? Retrieving the right document is the key, and it's not a rocket science, so everybody can do it easily. And doing like similarity search and getting the relevant document, it looks like so simple. But in here, there is a lot of hallucination is going on. So it's inevitable to, in this use case, in the rack use case, what if we got wrong chunk? So if we got wrong chunk, we are definitely gonna have irrelevant answer, or like some kind of answer that this resource or like this source is not relevant to the question from the language model. And what if we got repetitive info? So actually, large language models are really intelligent, and they know, like, in their system, in the behind of the LLM architecture, you're already doing this actually. And why it would be useful in this case? If you got the repetitive information from the vector DB, or like from the rack system, you are just gonna have some kind of hallucination going on again. And it's really important to implement this stuff with with carefully, and in that way you can't get hallucination or like some problems in the production environment. So we talked about vector embeddings, we talked about retrieving the right document is the key, and also in while retrieving the right document, you are doing similarity search and getting the most closest document from the vector database. So in the naive rack use case, so your user are just asking question, and you're getting this question to put into embedding model to transform into vector. So you can't get the question and do similarity search on the vector database. First, you have to take the vector, you have to turn into vector from the with the embedding model, and then you have the vector. So you're just having a call, doing a call to the vector database to get the most relevant, or like most closest document to this vector, and then retrieving it. And I don't know why this logo doesn't show up, but it was OpenAI logo. And then you are giving this document and the question into large language model to get better answer. So you already can have answer from the question, but we don't know if it's gonna have hallucination, if it's gonna have bad answer, or like there even guardrailing should be done after the large language model, because we don't know if your question has some bad wording and like racism or etc. The large language model can just answer you with the racism, uh, uh, and we need to like prevent those kind of stuff. So this is the simple RAG, like you're getting question, turning into vector, doing retrieval, and then getting the answer to the user. So actually, naive RAG could solve some of the problems if you have clean data. And it's also useful for the simple prototyping, like if you want to see if it's working or not, or like if you have minimal setup on your local, or like if you want to see the baseline performance of the RAG, like if it's retrieving the right document or not. But most of the time, naive RAG has this problem, like uh, since it's just retrieving from the query, you are probably gonna have low precision and recall out of it. And it's also inefficient with large data. If you have like a lot of data, a lot of clean or dirty data, it doesn't matter. So you need to have some kind of strategies to get this data to chunk it together into the vector database to get the best answer out of these all of these data. So this was the naive RAG approach, and this is more like a agentic RAG. So this diagram is from the hackathon I did like last week, and so Llama Index workflow is working more like an agentic way. And so in this project, first of all, let me tell you about the project. In the project, we have two courses, Python to production and cloud engineering courses. These are like for the Python engineers. And we put these two courses, the transcriptions of these two courses into vector database, Pinecone. And then also we had Llama Index workflow. And then all these things goes to Phoenix observability. Like you can trace your calls, everything in the Phoenix platform. And then after this, we are getting the Fast API Swagger to use this workflow. Like it's this workflow actually inside the Fast API application. And yeah, so first, these are more like a working steps, and each node is more like an agent. So first step is like initiating the index of the vector database. And then second step, if you ask question, second step is like preparing this question to retrieval, like turning into vector and everything, and then doing doing the retrieve from the vector database. But at the same time, in here somewhere should be some kind of re-ranker, and it's really important to implement re-ranker to get better answers and then generating the answer. So this is more like a step by step, and each step can go to next, or each step, if it fails, it can retry the step again. But in the naive RAG approach, there's nothing something like that. And normally, like there are definitely hard examples, but the hackathon that we did was 2 days hackathon, like 48 hours hackathon. That's why we make it simple and just implement it simplest way to finish the project. So in this agentic RAG, normally there are tool calls, which is like more like a function calling, or like you have tools that your LLM or like your RAG system has, can get calls and get answer from these tools, like use these tools actually. And then there are self-correctiveness, so each step has actually some kind of LLM behind it, like that that is making decisions if it's gonna go next or like retry again, or you can implement it without the LLM, of course. And then also you have control over the sub-agentic tasks. So in here, actually, you have more control if like retrieve or like generate. But as I said, it was a simple project. I'm just gonna show you more like complex projects in a second. And then also in this architecture, all these steps is actually asynchronous. So of course you need to wait before, but it's more like a asynchronous way. So you can have like scalability, you can implement it in this workflow. And then also customization, so you can have custom tool calls, custom functions to call, etc. And that's why it has more like a custom way. In this agentic rack, you can connect multiple steps together to get better answers. Let me just show you more like a complex approach. Actually, yeah. Also, there, yeah, this one is more like a multi-agent network. So each agent has these connection to each other, and one like you can give input to the system, and first it will go to the researcher, and it will use the search function on like searching on the web to get the best related information, and then it just messages to router. And this router is definitely LLM based router, or like as I say, you can implement it more like a brute force way. And this router will just route everything between these these agents. And if it will go to chart generator or like call tool, or maybe it can go to researcher again. And this was the nodes, and each, as I said, each node has like agent. So decides to execute a function call to retrieve documents, and then you can have conditional ages, or like you can have conditional conditions that if it's gonna continue calling it, or like uh, or like just continue generating answer. So you can get more and more data into the context in this way and get better answer. Anyway, let's get back to the presentation. So, and also I just want to talk about tooling, and these are the tools that I'm following it on the LinkedIn and like in every platform. So as orchestrator, LangChain was really good when it comes first, when it come first, but after some time, it just got more like a dependency hell issues, because it has a lot of connectors on with different tools, and with different implementations, integrations with other tools. And I can say it after, maybe after version 2 it got better, but I don't know. I'm mostly using Llama Index because it's more robust. But if I like, I haven't implemented Haystack pipeline into the production environment, but everybody says Haystack is better in the production because they were in the space even like before the generative AI stuff, like 2017 or something like that. And they have this robust approach to the generative AI and large language models. So they are like they are like not changing everything, and like not having dependency hell and everything, and that's why it's really better, probably better than these other two. And for the LLMs, I'm also using Cursor, which is a Visual Studio Code, the generative AI powered Visual Studio Code. It's actually a fork of Visual Studio Code, but under the hood, like it uses Anthropic Cloud 3.5 Sonnet, and these are like three most useful LLMs, like OpenAI GPT-4o, Anthropic, and also Google's Gemini. But these are two open source. Like I actually prefer Meta's Llama 3.2b or like 2.3.2 or like 3.1, because these are more like open source approach, and you can definitely have some kind of customizations or like fine tuning over these models. And for the serving and inference, BentoML has these. BentoML is an package that uses Fast API under the hood and turn your machine learning model into more like a API, and it's really useful. But this, like, I don't know why, but it's not so popular around the people who are using who are building generative AI applications. And Hugging Face has a lot of open source packages to use, fine tune, or like do some kind of inference optimization over your LLM, etc. And then Model is a platform that has serverless GPUs, and I'm not sure if it's the cheapest option, but it uses Fast API, etc. Like it's really cool that you can have some kind of Python file, and when you run it, it just goes to the Model platform, and it actually orchestrates all your code on serverless GPU platform. And there's Llama CPP, which is the best way to utilize your GPU to serve your own LLM on your local or on your other computers. And there is LeadServe from PyTorch Lightning. It also uses Fast API under the hood, but the difference between BentoML and this Lightning AI LeadServe is LeadServe use continuous batching. So in the scalability perspective, it's better than BentoML, because BentoML is just a one Fast API, and serving is done. So vector databases, Pinecone is probably the best out of all of them when it comes to hitting the right document. Each vector database has different algorithms behind it, and some of them has better on getting the relevant documents, and some of them has better scalability. So Milvus is probably the best performant from other three, and VV8 is also a good option. Qdrant, as far as I know, X.com, the Twitter, just uses Qdrant on their Grok LLM ecosystem, and I'm not sure about that. And also for the observability, I mean, I'm sure that they are using Quadrant, but I'm not sure about how they are implemented in the RAG in their product. And for the observability, in the GenAI team, we are using the weight and biases. But I just, like 2 weeks ago, I just moderated one conference, and there is one guy from MLflow, and he just told me that MLflow is definitely developed, like it's more robust and has more features than weight and biases right now. And there are other options like Arise. Actually, Phoenix and Arise is the same, but there are other observable options like Langsmith, etc. I just forgot to put it in here. So I just talked about agentic RAG and the naive RAG approaches, and there definitely has a lot of problems with hallucination and getting the wrong document. So we have advanced techniques in here to reduce the hallucination and getting the better accurate answers from your RAG system. So there are different chunking strategies. You can have parent-child chunking. So if your document has like 500 pages, you can have one parent uh, retriever, and it can retrieve some kind of part of your uh, document, and then like first 100 page or like second 100 page or something like that, and then after that child retriever will get the best document out of, like, it's gonna search again on a smaller smaller, how can I say, smaller part of your document. And also there is semantic chunking. So maybe your document, it has different parts that is actually relevant to each other, like every end of the section has relevant to each other. So with semantic chunking, you can get all these chunks, and you're just semantically chunked together, like every end of the section will go together, and in that way you can get the best results, because uh, the most relevant document those most relevant chunks will be together. And also there's re-ranking. So you're using LLM to re-rank your document again, like your chunk again, and in the future it will give you better results. And it's definitely useful to use re-ranking in your RAG system. And also there's query expansion. So you have question, and LLM will just expand your query, your question, to add, like, if your question is like about healthcare, just gonna have it's just gonna put some kind of and health tech or like technology around it. Like, it's gonna be more like a drive your expand your query in a way that adds some kind of wordings, etc. And you should have filtering, like it can be metadata based or like content based filtering. So in these documents we have these different folder structure, and this folder structure actually is more like a content sections, and that's why it was more like a content based filtering. But you can create more metadata for your documents. And if you know the use case of yours, you can implement multi-step reasoning, like different chains and then reasoning calls to LLM to get better answer. And then you can have definitely router, like maybe some LLMs has better in the topic of like math or like in the topic of biology, you can just route to that LLM. And also out of all these different techniques, choosing the right embedding is actually the best advice, because so if you have legal documents, you should definitely use some kind of legal embedding model to embed those documents into the vector database. And actually these are like several techniques. And so resources that I used: Llama Index blog post and LangChain blog post. Also there is this State of the AI 2024 State of AI report. So it's so new, by the way. It's actually, yeah, it just came out October 10th. And this report contains all the state of the art and what happened this 2024, this year, in the LLM world. And also I used this A16Z and Sequoia blog post to gather some kind of information. And that was it. Thanks for listening to me.